Now, students, straight back again. Today you got some notes for section 2.4, representing data. Your objectives: create graphics to reveal pattern in nature and interpret graphs. A lot of this should be just old review stuff for you. Review vocab: independent variable, variable that is changed during the experiment. Also called the manipulated variable. Only one little new term, a graph. And our key idea: graphs visually depict data, making it easier to see patterns and trends. This section, I don't believe Mr. Humber gave you anything on, so you might need a little better notes than you do on some of them. So, graph, definition, visual display of data that makes it easier to see than a table. So over here we do have a table, and this is a graph, particular a circle graph or a pie chart. A circle graph or a pie chart has wedges that visually represent percentages as a fixed of the whole. Pie chart, circle graphs, typically our keyword is there, percentages. Dealing with percentages, we frequently use a pie chart. Or you can think parts of a whole. Bar graphs vary across independent categories here, like different types of food. This is what we call discrete data. Discrete data means that there is nothing in between halibut and almonds. You got halibuts, you got almonds, you got cashews, you got spinach, but there's nothing in between. So using a line graph on something like this wouldn't make sense. If you use a line graph, that's going to be for continuous data, which would have stuff in between. So this is continuous data on a line graph. Continuous data. And key thing, independent variables plotted on the x-axis, dependent variables on the y-axis. Note here, we got elevation, you got a 100 mark, and you got a 300 mark, and you got a 500 mark. But between 300 and 500 is 400, another line. But even between that, between 400 and 300, you got a whole bunch of numbers. So this is continuous. Elevation, we could even go by inches, or a half inch, or a millimeter, or so we could have a lot of different things. Continuous data, same thing with temperature, and we have continuous data. It's very good to use a line graph. Discrete data, which is considered to be count is considered to be countable, is better for a bar graph. When we use a line graph, and we use a lot of line graphs in chemistry, not quite as many circle graphs and bar graphs, mostly line graphs. We got our slope formula here. You should remember from chemistry slope, and you'll remember the symbol was M, from Algebra 1. M equals slope, rise over run. Here we read this delta x and delta y, means change in y divided by change in x, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So, and we can use this. If it's a straight line, we can examine the slope. And a couple fancy words here, interpolation and extrapolation. Interpolation, find in between the points on a graph. Extrapolation, outside the data. Interpolation tends to be very reliable. Extrapolation, not quite as reliable. Because when you start going outside your data, things can change. And that's what times in trying to figure out origins of the Earth, origins of the universe, they start extrapolating back. And we don't know if things have stayed the same. So, extrapolation, not as reliable as interpolation. Ozone. So you can see what happens in ozone in this period and in a different period and compare them. So line graphs help us do a lot of comparisons. Yeah. We wouldn't have, I'd had different points of data on here, and you would interpolate to get the others. If we start trying to extrapolate these things back or ahead, we may get good data, we may not. Blank variables plotted on the blank axis in a line graph. So independent matches up with X. Independent does not match up with Y. Dependent does not match up with X, and we aren't using a Z variable here. If you do 3D graphing, which we don't do in chemistry, in the chemistry we're going to do, we don't do it. Could be times where we might want to do 3D graphing, then we could use a Z variable, but come along that in certain types of mathematics. Quantities vary across categories, bar graphs. You think categories, bar graph. So that was your 3.4 notes again. Good notes. Helps you learn, helps you succeed on the quiz. So that's it for now. Till next time.